Join me in the middle of ecstasy. Feel the melody in the rhythm. Hey everyone, and welcome to today's lesson about arithmetic sequences. After today's lesson, you should be able to determine whether a sequence is arithmetic. You should be able to write recursive formulas. You should also be able to write explicit formulas. And you should know what all those words mean, since most of those words are new vocabulary words. If I look over at the vocab, I can see that a sequence is an ordered list of numbers. Each number in a sequence is called a term. An arithmetic sequence is a special kind of sequence in which there is a constant difference or a common difference between each term. Sequences can be written in two different ways. They can be written as a recursive formula, or they can be written as an explicit formula. And we'll learn about what each one of those means as the lesson goes on. So, let's get started on the first example. Example 1 says describe a pattern in each sequence, and then what are the next two terms of each sequence? Well, let's start by clarifying that because this is a sequence, each one of these terms is numbered. So 5 is the first term, 8 is the second term, 11 is the third term, 14 is the fourth term, and so on. So let's look at the difference between each one of those terms. From 5 to 8, that's plus 3. From 8 to 11, plus 3. 11 to 14, that's plus 3. I'm noticing a pattern here. So if I continue that trend, the next two terms would have to be 17 and then 20. So this is an arithmetic sequence. And the common difference is 3. Let's look down at part B. I noticed that 2.5 is the first term, 5 is the second term, 10 is the third term, 20 is the fourth term, and then we can go and so on. So let's look at the difference here. From 2.5 to 5, I added 2.5. From 5 to 10, I added 5. From 10 to 20, I added 10. It looks like I'm adding double each time. So the next time I should be adding 20 to give me 40. And the next time I should be adding 40 to give me 80. This is not arithmetic because I'm not adding the same thing every time. All right. Let's look at example 2. It says tell whether each sequence is arithmetic. If it is, what's the common difference? Okay, I'm looking here. I see that the difference here is 5. From 8 to 13, that's 5. From 13 to 18, that's 5. So yes, arithmetic. And the difference is plus 5. How about part B? From 6 to 9, that's 3. From 9 to 13, that's 4. I can stop right there because immediately I see I don't have the same difference. This is not arithmetic. And that's sad. Looking at number 3, it wants me to write a recursive formula for the arithmetic sequence below, and then find out what's the value of the 8th term. So we're going to have to pump the brakes for a second here and talk about some of these words. A recursive formula. That's a formula that relates each term to the term before it. So again, it relates each term to the term before it. So I'm going to write this as a function rule. Okay, so I'm going to start off with an, and this represents the value of any term. So an equals, and again, I say I relate each term to the term before it. So we need to have some sort of notation to show the previous term. And that notation is this. It's an minus 1. This means the previous term. All right, now I look at the pattern here. The pattern is I am adding 7 each time. So this recursive formula would mean that any term is going to be the previous term plus 7. And that there is my final answer. an equals an minus 1 plus 7. So what's the value of the 8th term? Well, I just need to keep on adding. So this is my first term, second term, third term, fourth term. The 5th term is going to be 98. The 6th term will be 105. The 7th term will be 112. The 8th term will be 119. Now you can see that it starts to get a little bit tedious adding to the previous term. And that's why in question number 4 we have something called an explicit formula. In an explicit formula, it relates to the term number. All right, so in an explicit formula, if I want to find what's the 8th term, I would be able to plug in 8, and it would spit out the correct number, rather than adding to the previous term. So there is a general formula for this, and that general formula is any term equals the value of the first term plus the term number minus 1 times the common difference. So I'll plug in up here what that would look like. So for any term, and I'm using the sequence up in example 3, it's going to be the first term, which is 70, plus the number of the term minus 1 times the common difference, which is 7. Now, let's go ahead and simplify this. So I would see that it's an equals 70 plus, and I have to distribute this 7n minus 7, and I get an equals 70, excuse me, not 70, it's 70 minus 7, which is 63, plus 7n. Okay, this is a linear function. I could also do this following the logic of writing the equation of a line. So I could say that any term is equal to the slope, the constant difference here, which is 7n. And then in order to find the constant, I need to find that y-intercept, so I'd have to back it up and find out what would be the 0 term. What would be the term right before? And the term right before here is 63. So it would be 7n plus 63. Either way, whether you use the logic from writing the equation of a line or the general formula, which is shown here, you're going to arrive at the same answer. All right, now it's going to be your turn. Go ahead and flip to the back, and we're going to try the self-test. Answer questions 1 through 4, and then check your answers. In question 1, you should have continued the pattern and gotten 20 and 24. And in part B, when you continue the pattern, you get -7 and -12. Question number 2, when you have to decide whether it's arithmetic or not. Part A, it is not arithmetic. We don't have a constant difference. And in part B, yes, it is arithmetic. The constant difference is +4. All right, in question number 3, it says we're studying some new plant food. The plant starts off at 20 centimeters tall, and it's adding 3.5 centimeters per week. what will be the height after 4 weeks? You should add 3.5 4 times. So after 4 weeks, you should have a plant that is 34 centimeters tall. Again, I have to add 3.5 4 times to get 34 centimeters tall. Last one, an arithmetic sequence is represented by the recursive formula an equals an minus 1 plus 7. That tells me that the difference is 7. I'm going to write the explicit formula. So I could write using the general form where it's an equals the first term plus the term I'm looking for minus 1 times the common difference. So I could write an equals the first term, which is 2, plus the number of the term minus 1 times the common difference, which is 7. When I simplify, I get 2 plus 7n minus 7, and an equals 7n minus 5. I could also follow the logic of graphing a line. So I know that the slope will be 7n. If the first term is 2, I need to back it up to find the 0 term. So 2 minus 7 is negative 5. Either way, you should arrive at the same answer. All right, threw a lot of information at you today, a lot of new vocabulary. I hope you learned a lot and will come to class ready to get to work.